Hello guys, and welcome to today's lesson. Today we are starting Module 2. So we had the Mod 1 test last time, and now we're starting Module 2. Module 2, Lesson 2.1, we're going to spend about 3 days on that, just Lesson 2-1. So you're going to see Day 1, Day 2, Day 3 work, and then you're going to have a test next week on this information. So you're going to have a test on Tuesday, it looks like. So we're going to have 2-1, 2-2, 2-3, or 2-1, Day 1, Day 2, Day 3 assignments. So make sure that you're paying attention and getting all your work done. One thing that I have noticed is that those of you that are putting the time in, you're doing your homework, you're asking questions, you're engaged, you guys are scoring well. Kudos to you guys. You did a great job on your test. And those of you that are struggling a little bit, that in the classroom, you're not quite getting to your work, you're not answering questions, you're not finishing all of your homework, some of you are struggling a little bit. So just a reminder that the more you put into it, the more you try it and work it out and try to figure things out, the better off you're going to be. So your grades and scores are going to reflect how much work you're putting in. All right, let's begin this lesson. So we're going to start off, and math is a lot of patterns. So what we're going to do here is we're going to start off with the pattern, and we're going to start with just the number 3. Okay, and then we're going to have 3 squared. And I'm kind of going to be filling in a chart here as I'm doing that. And so, and just remember, if I'm going too fast, when you guys get to the end and we're done with this chart, you can always freeze and stop this video and go back to get some examples. Okay, so I'm going to be filling this chart in as we go. That middle column is basically just going to be work, and what we're really trying to do is figuring out some patterns here. So in here, what is 3 squared? That means 3 times 3, and we already know that 3 times 3 is 9. So 3 squared is 9. And we're just going to keep this pattern going here because math is a lot about patterns. So 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. So we know 3 to the third is 27. Well, let's just keep this pattern going on the top. That exponent's 2, the next exponent's 3, and our next exponent is going to be 4. Our next exponent here would be 5. So let's just keep it going backwards. What do we have? 5, 4, 3, 2. What would this exponent right here be? Well, that exponent would be a 1. Okay, and now what are we going to do next is if we have 3, 5, 4, 3, 2, 1, what number would come next after 1 as we are counting backwards? Yep, a 0. So now what number is going to be next as we go 5, 4, 3, 2, 1, 0? Then what do we get? We get a -1. And then lastly on our chart here, if we go 3 to the first, what? 1, 0, -1, -2. So we're just keeping patterns going here. So this one is going to be 3 times 3 times 3 times 3, and that is going to be 81. So another way to do this on your calculator, just to make things go faster instead of going 3 times 3 times 3, there's a button that's called a caret button, and it looks something like this on your calculator. So just to do this one faster, instead of trying to multiply it out, we're going to hit the 3, then you're going to hit that caret button on your calculator, and then the number 5. So you're going to hit 3 caret 5. And if you don't have a calculator, then maybe you can pause this video, go find a calculator so that you can do some of this math. All right, so we got our patterns going 5, 4, 3, 2, 1, 0, -1, -2. Let's keep this pattern going here. So if we're at 243 and I want to go to 81, what do we do to 243 to get to 81? What do we do to go from 81 to get to 27? What do we do to go from 27 to get to 9? From 9 to, because what we need to know is what number goes there. Well, what is 3 to the first power? Isn't 3 to the first power just 3? So what are we doing on the bottom to keep this pattern going left? When we went to the right and we went this way, we multiplied by 3 every time. So if we're going backwards and going the other way, if you take your calculator and take 243 and you divide by 3, do you get 81? If you take 81 and you divide by 3, do you get 27? Divide by 3, do you get 9? Divide by 3. So do you see the pattern is dividing by 3? So what is 3 divided by 3? Well, if you don't know, take your calculator and go 3 divided by 3, and you get 1. Okay, now the next one, another way of writing divide by 3, can't I take 243 and divide by 3? 81 and divide by 3. 27 and divide by 3. So here we're at 3 divided by 3 and we got 1. So now we need to take 1 and divide by 3. So we end up with this fraction of 1/3. Okay, now you can take your calculator, and if you know how to do it, take 1/3 and divide by 3. Well, if we take 1/3 and we divide by 3, if you guys remember from your rules in 5th, 6th, and 7th grade, we rewrite this number as 1/3. We change division to multiplication, and we do the reciprocal. We flip that. So instead of it being 3/1, we make it 1/3. Well, 1 times 1 is 1, and 3 times 3 is 9. So we get 1/9. Look at this pattern here. So we have a 3 here and a 3 on the bottom. We have a 9 here and a 9 on the bottom. Can anybody guess what 3 to the -3rd would be? So let's go over here to the third, and what number do we see? We see a 27. So I bet this next one would be 1/27. And what's the next one going to be? It's going to be 1/81. So what's happening here in all of this is that when we get to our negatives, negative exponents up here, negative exponents, what is my answer written as? My answer is written as a fraction. So 3 to the -2nd is 1/3 to the 2nd. So you see in the original problem that exponent is a -2. And then what happens, because mathematicians said that a negative exponent is not simplified, so they're making us redo this. So we write it as 1/3 to the 2nd, and that becomes 1/3 times 3, and it becomes 1/9. And that's exactly what we got. 3 to the 2nd is 1/9. That is exactly what we got. So if we take 4 to the -2nd, what's going to happen? Okay, that negative exponent is not allowed. So we write it 1/4 to the 2nd. So we have 1/4 times 4. So we get 1/16. It turns into a fraction. And we know this by looking at these patterns. So I could really kind of put any number in here. So let me just erase a couple things, and then we will put in some different numbers in here and see how it compares. So if I go in here and I just pick a 5 to the first instead, 5 to the first is 5. If I have 5 to the 2nd, that's 5 times 5 is 25. And then if we keep the pattern going, 5 to the 3rd is 5 times 5 times 5. That's 125. So if you take 125 and divide by 5, you get 25. 25 divided by 5 is 5. What's 5 divided by 5? Don't we get 1? So look at, we have 3 to the 0 power and we got 1. We have 5 to the 0 power and we got 1. What do you think would happen if we put a 6 in here? What do you think 6 to the 0 power is going to be? 1. What do you think 2 to the 0 power is going to be? It's going to be 1. No matter what we put in here, that pattern is going to end up. So we have a very important note to write in here. Anything to the 0 power is 1. Okay, stop this, freeze this, put this in your notes. Anything to the 0 power is 1. Now, this chart might be super confusing. Following the patterns, I'm sure you guys were totally fine. What you need to know and what you just need to memorize, because calling up this chart and coming up with this all the time might be difficult. So we're just going to go through some samples that everything is going to follow this same pattern. So what did we find out? We are not allowed to have negative exponents. So mathematicians told us we need to write this as 1 over 4 squared. And when we do that, we get rid of that negative and it becomes a positive exponent. So some of you can now just tell me what 4 squared is. So we can write 1 over 16. 5 to the negative third. At any time, remember, pause this video if you need to just stop and write it and then come back. So 1 over, and we're going to write this as 5 to the 3rd power. So some of you might know what that is. Some of you might need to go 5 times 5 times 5. And so we get 1 over 125. Now, some of you are going to get really good at these, and you're going to be able to go right to this answer, and it's going to be 1 over 49. Some of you are going to still need to say, oh, that's a negative exponent, so I need to write it as 1 over 7 squared. And now you can say 7 squared is 49, and some of you may need to just do 7 times 7 and get your 49. All right, so it doesn't matter if we have a number or a letter there, we still do it the same. Mathematicians say no negative exponents. So we write this as 1 over x, and remember when I write this exponent this time, you put a 4 down there. Okay, so it's just 1 over x to the 4th. So what is x to the negative 11th? So stop it, pause it, write your answer, and then start it again so that you're checking yourself to see that you're doing these right. So this is going to be 1 over x to the 11th. All right, what did we say? That anything to the 0 power, no matter what it is, it's just 1. So x to the 0 power, anything to the 0 power is just 1. All right, now we have to be careful on here because some of us just automatically go and say that this answer is just 1. But mathematicians do not write everything. So what this says is 3 to the 1st power, x to the 0 power. So we still have this 3 to the 1st power is 3 times, and then x to the 0 power is 1. So 3 times 1 is 3. So here, this one says 8 to the 1st power. If something, see in this next one, see how it says 8 to the 2nd? If they don't have a number written here, we have to assume that that is a 1. And this is x to the 0. So we have 8 times 1 is just 8. Now 8 to the 2nd power, that's what we've been doing. Remember, that's 8 times 8. So this is 64. So don't forget and think everything's 1 over something. If it's a positive exponent, make sure you leave that answer just like it is. All right, x to the negative 7. We cannot have this negative exponent. So mathematicians say we need to write it as 1 over x. And when I rewrite this exponent on the bottom here, I leave it as a positive exponent. All right, last 3 here. 4 to the negative 3rd power. So we have 1 over 4 to the 3rd. So we have 1 over 4 times 4 times 4. So we have 1 over, and what is 4 to the 3rd power? 64. All right, y to the 0 would be 1. X to the 0 is 1. 1 times 1 is 1. Y to the 0 is 1 plus x to the 0 is 1. So this answer is 2. All right, so your homework now is on page 36, 1 through 9. Watch your second video, and then you have it online. Good luck.